Having so much fun in chat, I forgot to go live. Welcome to the Oxford MAT live stream. I'm your host, I'm Jason Monroe. Hi, if you're joining us for the first time, the MAT is next week, and we are going to do some questions from last year's paper. But first, hi to the people who are watching live in chat and who will let me know if I've pressed the buttons wrong. The more live streams I do, the worse I get at it. I'm just never that good at, oh my goodness. How do I get chat on screen? You see, I've got chat on screen every week for like 4 years, and now I'm like, where is it? How do I do it? Who am I? What is this? Is it now? It's broken as well, so that it's not even helping me. Look, I'll show you chat. All of the chat I've got. I want to ask chat how their day was. Oh, we are live. Thanks, Miles. Miles in chat a minute ago said, why are we not live? And that was how I realised that it was 5 o'clock. I want to put on the vote for how was your day. I'll turn it on and see what happens. Good. Okay, chat will also let me know. Hi, David. Time flies. Alice, please use a pen in the booklet. I'm just saying this because we're going to scan the booklet, and every year I'm naive and optimistic, and I think that pencils will scan fine, and every year I get pencil that hasn't scanned well. We're going to scan it, so please, pen if you can. I know, I'm also the sort of person who would prefer to write in pencil, but oh my goodness. Right, okay, what are we doing? We're voting on how our day was, and people are voting, so they would let me know, right, if I couldn't get the thing. But I've now lost the other thing. Honestly, how do I get worse at it every time? Okay, here we go. Bam! Chat's on screen. Sort of. You're voting on how your day was. Your day's currently good, so that's nice. That's really pleasing. I'm glad you're having a good day so far. I am too, I think. I am slightly dressed, someone said that. Time flies, yeah. Correct, yes, correct. I would also ask you to sketch in pen. Sorry, people in chat asking about pencils and pens. Genuinely, in the rest of your life, yeah, great idea. Pencils, pens, different stuff, different colours. For the exam, I'm afraid we're going to focus on being really legible when it gets scanned. And because it's being scanned, who knows, right? We'd just like you to use pen, please. The instruction on the front of the test is going to say, please use pen. Herb is now going to overthink it. Right. Is the 2023 paper fun? Yes, but I think I said that last year and indeed every year. I think it's a good one. There's a question in chat. It's not stupid. You're asking about, I saw this just before I went live. You're asking about using the bathroom drinking mat. I don't know, I'm afraid, sorry. Some of this stuff is being sorted out between test centres and sensible people who know about how exams work. I mostly just write maths questions and not decide on bathroom breaks. I don't know. Notgal says, "Is it scanned in black and white?" And again, I think it's scanned in black and white. Has been before. Would you describe this year's paper as maths? Yeah, I think I probably would. Good. Right. Okay, we're having a great day. This was amazing. It's probably the best day you've ever had. Why are we doing maths? Is that going to make things better? Yeah, there's some 1-star votes coming in at the end there. Right. Good. Okay. Oh, and chat's now working on screen. There we go. We're doing the thing. Nobody touch anything. It's all going fine. Isabella's got a uni offer. Bread. In chat, everybody. Excellent stuff. Miles wants to know if the answer booklet has little graphs sketching stuff. I think I have to say no comment. The observant people will notice that I think since I started this job, we haven't done any little graphs in the answer booklet. It's all been freeform. Oh well. Oh, bread is, so someone says, what do you mean bread in chat? Bread is, I think, what people say when they get a uni offer. I think. Back me up, chat. No? Okay. I might have made up some teen slang. There you go. We've started something new. And they're like, full bakery if you get all 5? I don't know. Back me up. Okay, right, good. When do you get your MAT results? You get them back if you're applying to Oxford in January. We give them to you at the end of the Oxford admissions process, so that so you're not like stressed out during the middle. We do for other universities later on. It's part of the admissions feedback. The kind of weird thing about this test is it's part of an admissions process. All the other tests you're doing are kind of separate, I think, from admissions processes that you sort of do your A-levels and they're kind of separate and some linking up, but they're kind of separate. Whereas this test is weird, it is part of an admissions process. Whatever. people on chat are backing me up, but only, oh dear, only in the context of the sixth form subreddit. So I think I've accidentally outed myself. Oh yeah, look, there's a Reddit link. Good times. So you find out you're shortlisted quite a bit after the MAT, actually, at some point in November. Please don't stress. We do give people notice before their interviews, and we do let people know either way. The MAT paper is top secret on the day of the MAT, and we put it up the day afterwards. These days I traditionally make a MAT in 10 minutes video. Let's do a poll. Multiple choice poll, because I think this is... you might have seen these videos before. It started as a kind of meme. The name is inspired by those kind of speedrunning videos where something happens very quickly. The poll is going to be, would you like, just after the MAT, before we've published like mark schemes or whatever, or 2-hour video or whatever, would you like a 10-minute video that goes through the solutions very fast? Oh, Miles has explained, you put your application in the oven to bake, and when it comes back, it's bread. People at school say, I've been told, teen slang, people at school say, offer. Thank you, Anonymous, that's brilliant. Exercise 1, working out on the exam paper. Yes, Andrew, the rule for MAT is always, please do all of your working out in the booklet. So in the old days, this would be a gap, a space like this, whereas in the new days, the page is now blank. There are no questions in the answer booklet anymore, I suppose. So there's now lots of space for doing scratch work. Next week is MAT. There you go, don't be worried. People are asking about writing in black. We're going to scan it in black and white, I think. I reckon you can get away with writing in blue and no one will notice and no one will care. Please don't write in like yellow or something, but you know, you wouldn't write in yellow, would you? Friends wouldn't let friends do an exam in yellow. I think people are going to say they want to write. If you want to write in yellow for like some sort of vision reason or access reason, then I'm not knocking that, but good. Hot take. So questions behind the scenes. People have voted for the MAT in 10 minutes video, so I guess I'm making that. Interesting market research, thank you. You better watch it if I'm going to make it. It is formatted as a MAT speedrun. It's not any percent because I do all of the questions. Any percent would be if I did the minimum number, but I don't know. It's a kind of all endings run. Right, yeah, you answer the questions on paper. You don't get extra scrap paper, you don't get extra paper. We're doing all the MAT questions now. If you've just joined us because you wanted to ask a question about MAT, then hi, welcome to the show where you do that. Marks for each question to be shown on the paper. Yes, Jay, that is something we're doing this year. On the questions. It wasn't on the practice one, no. I'm aware the practice one doesn't, well, it has last year's questions in it, obviously, but also it has a sort of halfway house. There's been some development on the system since then. Sorry that it's not as good as it should be. It's also an imitation of the. It's not running the actual software. It's running an imitation of the software. These things are web development is not my thing. Good. Okay, I am getting way behind with chat, so I'm going to just approve a bunch of things. Solutions come out about a couple of weeks later. If you write in pencil, I might not be able to see it, but if I can, the rule is always. If I can see it, if my markers can read it, we will mark it. Please write so that we can see it. If you make, yeah, I'm not sure you know. Yeah, so this is the question I want to pull out, right? I'm not sure if you know how to make it dark enough, right? I don't want you to email me afterwards. I don't want you to email me afterwards and say, I had a lovely answer for question 5, but I'm worried that I wrote it very faintly. I mean, I don't want to get that email from you, yeah? Because if I get that email, that's devastating because you wrote something brilliant, but I don't get to see it. That's terrible. I can't let you back in the exam to go and write it again, right? So to avoid sending me that email, maybe use a pen. Okay. How do I prep for MAT in a week? That's going to be tough, but luckily, you've already been preparing because you've already been learning maths and doing math stuff. Right, I'm going to try and get up to speed with Matt. Yeah, Not Gas would like to start. I haven't read anyone's personal statement yet. I don't write all of the questions. You can't find practice math. Can someone helpful put a link in chat to practice math online paper? Or not, or don't bother, because it's just, no, don't bother. It's just these questions in a bit of a weird formatting. Don't bother. A in maths is probably, it's not what we're looking for, but I'm going to guess that's a predicted grade, not an actual grade. Or if it's a grade you've already got, then maybe you're doing it again. Please draw in pen, please write in pen, please do it pen. Is every MAT revised in the UK? MAT is set in the UK, is that what you mean by us? Oh, thank you, Herb. Yeah, I've realised that's not quite what they meant, but thanks. And David has linked to somebody else's work solutions. David, how dare you? Do we even let this happen? Are we going to let this on stream? You've come into my house. You come into my house and you promote other math solutions? Other people doing the questions? Excellent stuff. Right, okay. You do not have to add math as a qualification. We'll know if you're taking it. Miles got the joke. Good, okay. Also let us know in chat if you get the jokes. Right, good. We're going to start. I'm going to do a poll for which questions we're going to attempt live. There's the poll. You can vote for multiple things. And let's take a question while you're doing that. Question, I'll read it out. Why is the format so bad in the online practice paper? Like, the equations look so weird. I agree. My team and I have been working really hard behind the scenes since that came out. We're going to be very professional here. A lot of work went into that practice test. It was not signed off by everyone it could have been signed off by. I agree that the typesetting in that is not up to the standard that we put into MAT Parts papers, and then you'll be pleased to know that is not the standard that we've put into the actual MAT paper. Since that practice test was released, actually quite a lot of work has gone in behind the scenes to make the maths look prettier, because that matters a lot to me. I think I did that professionally. I think that was fine. That was unarguable, right? Fine line, right? Hi, if you're my colleagues and you're watching this, then I do love you all very much, and we're all working very hard. I just happen to care about twiddly little inequality signs. Good, right. Advice for question 5 or 6, but 2 and 4 are winning the vote. Ah, right. Okay. 2 is so good. 2 is so good, he says in a more normal voice. I'm not sure I've got a chat moderator, by the way. If you're watching this and you are an Oxford student who is moderating chat right now, could you let me know in chat that you're there? If you're not there, then that's fine. Don't worry about it. Herb is, I should say, this is the 2022 paper. Herb's off. If you don't want to see the 22 paper, then this is your last chance to not see the 22 paper. We're going to do 2 and 4. We're going to be live for 2 hours doing this paper. We're starting at about 1:15. I don't want to go through the online version because the typesetting's not what I want. It's just irritating to me. Good, okay. Yeah, and we're not going to get you to annotate things on the website. That's just writing things. Okay, there was some voting there. Question 2 won it, I think. So we're going to do question 2. Okay, my plan is to do about 15 minutes on this. As you're practicing MAT papers, part of it is about speed. It's not all about speed, but the skill that I think I can really help you with is understanding and putting together what's going on in the question. Let me tell you what this question is about. This question is about generating new solutions from existing solutions. So the question asks you to start off with, so somewhere in here, the question asks you to find numbers that do this with kind of small values of x and y, and then find bigger values of x and y. No, wait, that's not what's going on at all. I'm completely wrong. I'm thinking of a different question. Rewind. Timestamp. So the question gets you to solve different versions of an equation with different things on the right-hand side. If you've got thing squared minus 19 times different things squared equals a particular number z, then this tells you how to get a similar sort of shape of equation but equal to z squared instead. And there's other ideas we'll develop down here. And the idea is just to try and develop that until you can do it kind of on your own with 17 instead of 19. There's an idea in the question about how you might do this. This is pretty much like how interview questions work, by the way, if you're interested in interviews. There might be an idea and then an adaptation of the idea. Yeah, if you're saving this paper for the last minute, then here we go. Good wordplay, good. Comparing coefficients. Oh yeah, okay, yeah. Yeah, polynomials are good like that. Good old polynomials. Andrew, you should not be scared. Most people do not get 100 on this test. Most people do not attempt every part of every question. Including most people we take do not do every part of every question, even slightly. Right, good, okay. Let's do this. The number n turns out to be the number 19. To make the question slightly harder, it's slightly disguised. But we're going to try and show that this is true for some value of n, and determine that n is 19. Here we go. So the maths here is something like, expand out this and compare it, hoping that things cancel out. So I believe that there's a term that cancels. So if I want z squared, what do I know about z squared? Well, I know that z squared is this. So I'm going to put 19 squared here, y to the 4. I know that z squared is this, and I can see some of those terms in there. Oh gosh, if n is 19, then this is just 19 squared y to the 4 and some other stuff. It's got the x to the 4, it's giving me 19 squared y to the 4, it's giving me cross term, and everything's kind of linking together. So really I'm just sort of checking that n equals 19 works. That's my plan for this part. Matt is non-trivial. And we've received some applications, but I haven't looked at them yet. I'm waiting for the deadline. I think that's fair. Trial and error. Yeah, I've got a little bit, I think. So finding z if you know the values of x and y is easy, because we have a formula up here. I suppose I should calculate this. 19 times 9 is 1981, it's 171, so this is -2. And then, oh, okay, so this made -2, and now in order to make 4, I guess I've got that z squared. So I need to calculate these numbers. So I just need to find x squared plus n y squared. I know what x is now, and I know what n is, and work out 2xy. And this is a way to generate a solution with a different thing on the right-hand side. Before, -2, and now 4, which is z squared. Okay. So now we're asked to hence find. So maybe I should calculate these, because hence always means using the previous part. If you're new to the stream, some of it is understanding the language that's used in the questions. Hence always means follow through, like this. Okay, from the thing we were just talking about, and it's kind of an instruction that you need to follow. Okay, I'm going to work out x squared plus ny squared, which I'm not really looking forward to. Who wrote this? Oh, I see, it's plus from the previous things I was just doing, so it's not too bad. I already worked out these numbers. This is 169 plus 171, which is 340. And I also need to work out 2 times x times y. What was y? 3, which is, oh gosh, 26 times 3, which is 78. Is that right? Really cheeky. Yeah, no, I think I believe that. Chat will let me know. Yes, for pi. Good formula in chat, like this. Look up. Good, love it. Very good formula. A difference of 2 squares, right? Okay, I'm just thinking about 26, sorry. Multiplying in my head, good. Okay, so we've discovered around about here that, let's just make a little bit of space here. By the power of this arithmetic, to identify new number squared, take away 19 squared, that gives not z on the right hand side anymore, but z squared, we've discovered that 340 squared, take away 19 times 78 squared, is equal to 4, which seems a bit unlikely that such huge numbers could almost entirely cancel. But there we go. Somebody asked if you get a really good math score and a really good interview score. That's pretty impressive. That's, I would say, more interesting than your predicted grade, but opinions differ. And, we do look at things like predicted grades, but we look at everything together, and we get humans to judge it. Doing A-level. If you did A-level maths in year 12, we would expect you to get A star in it, and if you've got the A star, cool, carry on. I mean, that's what we're looking for. That's what you've got. Good, carry on. Well done. I mean, congratulations. A star was good. Okay. Hence him, he's using this previous thing. So this is my clue. I mean, notice that finding positive whole numbers x squared minus 19y squared equals 1 is really hard unless I'm given any context of how to do that. Now over here I can realise, oh, I want to kind of divide by 4. So I've got this trick for squaring, which I don't want to do again, because if I square, I went from minus 2 to 4. If I do it again, I'll go from 4 to 16. Things will get worse. I sort of want to divide by 4. And luckily, square numbers are good like that. These square numbers on the left are even. They're both multiples of 4. And in fact, if I just divide each of those numbers by 2, then I get something very plausible. I'm going to really cheekily check my numbers. I know this is not how the mat works, but oh boy, I need to get this right. Don't look. 900 and 39 squared, 19, 288. That's amazing. Never gets old. Super good. Right, cool. Judge. Okay. So we found these numbers. X squared minus 19y squared is 1. Beautiful. Absolutely. And they're massive. And these things just differ by 1. So good. Is this my only such pair of numbers? The answer to this is no. Because... and then run it again. Run this squaring thing, right? If z is 1, then z squared is also 1. So I could do, and I should really not work out these numbers, it will not go well. But here's another example. 170 times 39 squared equals 1. So I like this question a bit because it reuses the idea up here about squaring in a slightly different way to generate a new solution that works. Hi, if you just got here, everything you've missed is on the screen. We've been working through question 2 of MAT 2022. 2. Yeah, where did these 340 and 78? They came from x squared plus ny squared and 2xy. I just worked them out for these values of x and y. And once I've worked it out, then in brackets, this was 340. And in brackets, for these values of x and y, this is 78. It's equal to z squared. Z was minus 2, so that's 4. So just calculating with the previous thing. It's like an example of this for particular numbers x and y and z. That is tricky to think about because often if you've done something very general to then restrict down to something very precise and very specific, it can be difficult to see how to do that. Couldn't have predicted grade because country system is a UCAS, didn't really get it. You don't have predicted grades, your referee adds predicted grades. So if you've listed qualifications, then your referee will be asked to predict grades. So you'll be good. Cool. Is it intuition that's n equals 19? No. You can do something where we know this very solid fact about things cancelling out. If you apply that here, you can get this down to an equation involving x and y and n. We want this to be true kind of for any such x, y, and z, so we can compare some terms in that equation. I've gone quite fast because it's not very interesting algebra. Like on a bit of paper, you should, if you want to try this, you should multiply out these squares, compare with what you get when you naively square this term. Most of the terms match up. There's some cancellation. There's like a 2n minus 2 times 19, which you need to be 0. So that's pretty suspicious as an equation, right? And that's the coefficient of x, y, which you can do. And there's a coefficient of y to the 4 as well, which magically also works out because it's like n squared minus 19 squared, which you want to be 0, I think. I have y squared. Cool. Where are we going? Down here. Going up and down. If you guess the value of n, yep, seems fine, so long as you also check it works. What exactly did you do in part 3? Oh, I divided both sides by 4. So I divided this square by 4, which I did by dividing the number by 2. It counts twice because of the square. I divided this term by 4, same thing. And I divided the right hand side by 4, that bit's easy. And that gave me smaller numbers, which instead of giving me a difference equal to 4, gave me a difference equal to 1. You know, divide both sides by 4. The cute thing is that these are both even, and this is even. So this is an example where everything's even, so you can kind of reduce down. People in chat are asking about gap year applicants. We get a few gap year applicants. Often they've got a bit of a plan for some maths to do. Often they're doing a lot of math papers. We don't have any policy of making offers harder, but I think it's reasonable to expect you to do okay in the MAT or relatively well in the MAT because you're a year older than other people in terms of mathematical experience. Nothing else. Why are there more solutions? Oh yeah, I inserted them back into the equation again. I ran the machine another time. So running the machine again here is, now that I found this thing, the special thing about 1 is that when you square it, you get the same number back again. So a minute ago I was banging my head against the idea, oh no, if I put these numbers, 340 and 78, into the equation for x and y, as x and y values, then I'll get some huge numbers where the squares differ to give me like 16, because on the right we'll get z squared. So we're really using this like machinery up here, this thing from part I where we worked out that if this, then that. If this, then that. So if you've got a nice simple equation that equals 1, then here's a complicated equation that equals 1. That gives me another solution. It's a bit of a joke, right, that you're not supposed to calculate these numbers, just the fact that they exist is the interesting bit. Part 4, is the difference of two squares correct, SB? 25 square, so this is x minus 5y, x plus 5y equals 1. We're kind of morally done. There's a little bit of fiddly algebra down there to check that those aren't both the number 1, which they could be. There aren't very many ways to factorize the number 1. I guess they could both be the number 1. They could both be the number minus 1. Those are both kind of obviously impossible, so none of those go anywhere. But there's a tiny bit of work to do down there. Okay, but this part is kind of like I can't remember how many marks it was. This year we would print it on the question like here. I can't remember, I guess it's like 1 or 2. But this is like a sort of separate thing. It is probably just here to make the question longer. So there's an extra question. And 5, the last part asks you to kind of just do it again. Now the challenge when you do it again is that n is 17 now. The number n kind of always matches that number, but you should check that. You need some sort of starting idea. So you need to have some numbers. Maybe this is the trial and error that somebody else mentioned in chat. Now you could just guess numbers that work, in which case you're done and you can go home. But you might like to try some small numbers. And what you might find is that, well, 17 is pretty close to a square number. It maybe reminds you of the number 16. Maybe, I don't know. So something I tried was x equals 4, y equals 1. So that I get kind of two similar things. You kind of want this number to be about 17 times as big. And I don't want to think about big numbers. So let's think of some small numbers where one's about 17 times as big as the other. That kind of doesn't work because 16 take away 17 is actually minus 1. But then I can use the squaring trick, right? So if you see minus 1, then you should be thinking, aha, we're almost there because z squared will be 1. So my plan is to use 4 and 1 and then run it through the squaring machine. Yeah, I've done this question so quickly. After my experience last week, so last week I spent like an hour on the first question and it felt grim. Quick questions from chat. Do you have to say there are infinitely many in part 3? No, good spot. I like your attitude to maths, I guess. Can't give you any marks for it on this particular question because it's not part of the question. But like the way you're thinking. There are infinitely many because your maybe next thought here is like, well, we just generated these huge numbers, and then maybe your thought is like, I'm gonna do it again. And keep going and generate even more enormous numbers, even more implausibly. The difference of the square and 19 times the square of the other one is exactly 1. again and again and again, larger and larger numbers, each one about the size of a square of the previous one. They're huge. So 5, you would get all the marks if you did trial and error. I think, and this is mean, I think we selected 17 as an example where the smallest working example is quite large. One of the reasons I like this is that there is a kind of surprising relationship. And I'm not going to say anything about that relationship, there's not much I can say, between the number 19, 17, ... and the smallest solution, if there is one. We've seen from this part here that there might not be one. There's no solutions, right, in part 4, so that's kind of cool. The number in the question. So with 19 we've got this example where the number's not too big. For 17 we get another example. The example's not too bad at all. In fact, maybe you could work it out or just guess it. Or just get there, right? How bad would that be? So you check, I guess, values of y and look for squares. So you go like 18 is not square, and then you try 17 times 4 plus 1. I really don't want to calculate that. 69 is not square. Then you would try 17 times 9 plus 1, and 90, 63, 153, 154. I'm getting bored. Then you might try 17 times 16, and now are you good? No, I think you've got to get up to 64 is the thing. So you'll try up to 8 squared. And by that time you've done like massive calculations, so respect. Prove that 2 square numbers cannot differ by 1. Yeah, that's a good idea. Yeah, that works well, I think. Aloe wants to use Bazoo identity. We need square numbers. Oh yeah, Ben Turner in chat. Full name in chat, Ben Turner. Okay. Now use the machine. We have this machine that converts z to z squared. So yeah, correct. 16 take away 17 is -1. Apply the machine. So we're going to get out the machine, and the machine says to do 14 squared plus n is now 17. I think we'll check that works. Check in your own time, check that works. 17 times 1 squared. And then n is now 17 over here as well. The machine's slightly modified. 2 times 4 times 1. And my claim is that that's equal to 1, based on the algebra that we did right at the top. Algebra's great. Algebra lets you do loads of things for loads of really implausibly large numbers all at once. Brute forcing it, yeah. Is there significance in 17 and 19 being prime? Off the top of my head, not sure. I don't want to say no. But, you know. How do we justify 4? Oh, yeah. It factorizes, right? It factorizes, and then you're telling me you have integers that multiply to 1. That's weird. I claim that is so weird that it doesn't happen. You've got to follow through it a little bit. What integers do you know that multiply together to give 1? Not very many. Not many cases to check. It's a little bit fiddly checking those cases, but we're good, I think. If a question on the mat doesn't ask for working to be shown, should we assume that we should show marking? Lots of shoulds in that. Is it true that we get the number of marks available showing per part? These are both kind of quite confusing questions. Sorry, you've thrown me. 2 seconds, sorry. I think I'm in favour of always showing a bit of working. I know that's controversial. These questions do say justify your answers sometimes, right? In which case we should really show some working out because we're told to. Down here it doesn't. I think you'll probably include some working out anyway. The number of marks you get is the maximum number of marks you can get for that part. I think that's probably the most helpful thing I can say. Ben completed the square. Ooh! And then it is relevant that 17 is prime because either x minus 1 is a multiple of 17. Or x plus 1 is. So then you like check x equals 15 or 16 or 18, and then you actually get it straight away because 16 works. Is that multiple of 17? Really doesn't look like one. 89, it's 34 short, so it's 17 times 8. 17 times 16. So it does work. Why is not 4? Oh, I'm being an idiot, but you know. Yeah, cool. I like it. Difference 2 squares. Cool. Yeah, so for the first time ever, we're going to print on the questions. Well, print on the screen. Print on the screen? We're going to show on the screen. It's going to be like here. It's going to say like N marks. Wait, no, N is 19. X is 3. D marks. P marks. Oh, look, I did a normal shaped P. Q marks, or whatever. Like at the front of each part of the question. We're doing that for the first time this year. I don't have any examples to show you, but you will understand it. Ah, Ben says 8 squared now. Anonymous at the top of chat. I believe that you can log into the portal yourself and tick the boxes to say that you're applying for Imperial and Warwick. I think candidates can log into a portal, I'm told. If not, contact Imperial and Warwick, tell them you did the MAT, tell them your MAT number, MAT registration number, they'll work it out. Good. Why aren't basic calculators allowed on the MAT? Normally I say they wouldn't help you very much with the questions, but that is a bit rich of me since I just used one on a question. If you start allowing calculators, you have to say lots of stuff about what sorts of calculators you're allowing, and then it's kind of hassle. It's easier to just write questions where you don't use a calculator. The physics department have gone for the other ones. It says, I'm a cheat in the mat. Wish me luck. And I'm wishing you bad luck. Right, okay. We have a little banter. GCSEs at top of chat. Before I do question 4. We do look at your GCSE scores. There is even a little bit of weighting on GCSEs. I know I normally say there's no weighting on things. It's just a recommendation, but I do a kind of linear combination of GCSE data and MAT score, and I use that to, we've done some statistics, tell tutors roughly a kind of score that combines those things together. It's not the only thing we look at, of course. It's not all on my random bit of statistics, but that's one way we look at the GCSE data. We did some stats, and we know that the GCSE data is not as useful as a predictor as the MAT data, which makes sense to me. We look at it. The answer booklet has got spaces for your candidate number. I think you're instructed this year to write your candidate number in the top right of every page. Anti-anonymous, the opposite of anonymous, asks about in-school rankings. Hey, now we're talking about my job. Oxford gets some of this data. For mathematics, I don't use it in this. For maths, we're not using that data. I think it's the safest thing to say. Yeah, like, so if you have one bad GCSE score but 9 good ones, that tells me that probably you just had a bad exam, and that's not really doesn't really tell me about your mathematical ability, does it? I think we can all agree. This question 4 here has got a little bit of a story to it, which I might tell you at the end if we get through it by 6 o'clock. Okay, should we do this one? If you run out of paper for a question, you should continue on the pages at the back of the booklet. It says this on the front of the booklet. I'm just reading the booklet from memory now. You might also continue on just other random pages in the booklet. People have done weirder things in the past. You might just write your answer anywhere on the paper. The people marking it will have access to everything you write. It's helpful for them. They will smile if you write, please see page N. You don't have to do that. But if you want to make an Oxford grad student slightly happy, you could you could write a tiny note to say, see you next page. Just to let them know. I will be instructing them to look at the next page either way, but you can make their job slightly easier. Yeah, I've heard reports that the portal's not working right now. When we're not live, I'm going to report that to my colleagues who work on test centre preparation and admin stuff. Good stuff. So Chelsea, don't need to apologise. Good to have you here. Good, okay. Last minute tips for the map. I'm kind of trying to put them all in all of the questions, right? Oh wait, hang on, I'm reading out questions that haven't been approved yet. Sorry, Sashar. Good, okay. Let's go. This is a graph sketching question about drawing stuff. So there's a graph here which is like square root of x minus x over 4. The combination of these things does something like this, up. The square root wins to start off with, but then it comes down again. I'm saying the square root wins because x over 4 is a pretty chill function. If you look near the origin, x over 4 is pretty chill, whereas square root x has got a lot going on around there. Excuse me, really steep. So I'm trying to draw something that goes up really steeply because square root is kind of winning. If you add together a chill, relaxed function and an excitable function, then you get an excitable kind of answer. That's not real maths. Okay, long term, square root chills out, and it chills out to be really quite slowly growing. Changes quite slowly over there. You know, it kind of flattens out. At which point, x over 4 starts to look like the enthusiastic member of the pairing, and that wins. And it's got a minus sign on, so we end up very negative. We might like to solve for where this thing is equal to 0. I believe that is the number 16. And we might like to find the coordinates of the turning point, especially because we are instructed to do so, for which we will need to differentiate. And that happens at 4. Is it 4? 4 to the minus 1/2 is 1 over 2, and that does work. Good. And the value up there is root 4 is 2, take away 1 is 1. 2 take away 1 is 1. Welcome to the Oxford MAT Livestream. Oh, the portal out there is also broken, is it? Yeah, okay, great. We're asked to describe how it's related if we do this kind of combination of transformations to it. I think a couple of things have happened. So clearly x has been replaced with 4x plus 1 over here, in a way. But if I do that over here, I'll get minus a quarter on the end. So it's then minus 3/4 extra at the end. And I'm kind of thinking of that as an afterthought because it's all the way over here, and also because the order of operations really is like, you could just subtract 3/4 at the end. You know, I'm imagining how this 4x plus 1 would, if you just replace the x with the 4x plus 1, then you would get minus x, but you would also get minus 1/4. I can't see minus 1/4 in the page, so I can see minus 1. Oh, anonymous, great news. Sorry, distracted. I have the option to add other unis on the candidate dashboard of the MAT portal. That is brilliant news. I'm not a candidate, so I don't get to see the portal. If you're applying to Warwick for a course that needs the MAT, if you tick that box, they're just going to get sent your MAT score. It's going to be brilliant and smooth and seamless and secure. There are other ways you can give them your MAT score, but if you tick that little box, somebody else deals with it for you. How big a chance is there that probability will come up? P somewhere between 0 and 1, I think. I'm so terrible. I'm just awful. Right, okay. So x going to 4x plus 1. I see that kind of as 2 stages, right? I have to think about this really carefully. It is a MAT flashcard, one of the flashcards on our website, which you might like to have a look at if you're getting ready for some last minute revision. The flashcards look like this. You can download them from the MAT website, which you can find over there. And once you've got them, you can revise what a prime number is. Good. This is not the last live stream I'm ever going to do, but it's the last one because before MAT, which is next week. I'll tell you more about my plans for the future at the end. Andrew would like to access the online mock MAT exam. I'm going to try and find it. We had a go at finding it earlier. I'm going to find it for you. Everybody think about how to do those transformations, and then I'm going to get it wrong in a live stream. Actually, yeah, let me know in chat. What combination of transformations is this? Please let me know in chat. What combination of transformations is that? You got to do some scrolling, Andrew. But there's a link here. It's coming. It's coming. Oh, what? Slido. Slido, be good. Be good. Be good. Oh, come on, Slido. You can do it. Link. There you go. Did it. And look, nobody else posted anything in chat in between, so it's all like a perfectly closed loop. There's noise on the building site, which has suddenly died down, and also chat's just gone really quiet, which makes me think there's a power cut, and I just haven't noticed yet. What's going on? Hello? Oh yeah, no, here we go, here we go. Oh yeah, okay. So it can't be a power cut, the screens are still on. I'm an idiot. Right, okay. Right, so is it one first and then the stretch? First have one and then multiply by 4. And Pranav says, I loved it. Pranav says, from my live streams. I taught you, and now you know it and I don't. The knowledge has been transferred. Yes, okay, brilliant. Translate, stretch, then translate. Chat's off and away. Yeah, if your referee can't do predicted grades, then please talk to your college, Oxford College or other universities. They might try and get in touch with your referee, they might get in touch with you, but just talk to the universities. Have I met Boris? I feel like I've met Boris. I've definitely met someone called Boris who was doing math stuff. Hi again, Boris. Nice to meet you again. Oh, sorry, rereading that. Nice to meet your friend. Your anonymous friend, who might be called Boris as well. Cool. Good. And new turning point. Thank you, Anti-Anonymous. You apply those transformations to find the new turning point. This is lovely. This is just lovely. I can just ask the questions to chat, and you can do them. Right, okay. Part 3, we're asked to find points that lie both on the x-axis, where y is 0, and also on the curve C. The curve C has got this weird definition. It's points which satisfy the equation AP times BP equals 1. Those distances multiplied together to give 1. I feel a little bit bad for the person who is very excited. There's someone in chat who is very excited about the engineering test. Their chat messages are not getting through. Oh, right, okay. Andrew wants to know about translate, stretch first and then translate. I think that doesn't work. It's very tempting, but I think it doesn't work. We need to do some sort of test, Andrew. It's not the same, I agree. What is transformation? Yeah, okay. See, I'm joining in again now. I tried to just sit back and get chat to do it, but I've got to do some teaching. So, one way to imagine these transformations is a stretch. I'm going to scroll, I think. Yeah, scroll like that. Give us some space. Here's the definition of C. You're going to tell me whether. Give me back my freedom. Give me fire. Give me anger, or I retire. This is great. I think that's the one that got through. That's the one that got through. There you go. You can have that one. That'll do. Oh, engineers, what are they like? So a stretch by a factor of 1/4 parallel to the x-axis. In a way, that means replace each x with 4x. So if you see something like 2x squared plus 3x plus 1, then this stretch means that you actually end up at this equation for your new curve in the new world. I think a translate by 1 unit right parallel to x-axis, that's something like replace each x with x minus 1. This is one way to think about it, where you do this. So my parabola would go to x plus 1 squared plus 3x plus 1. Oh, minus. That's not the classic way to mess up the minus sign. That's a new and interesting way to be stupid. Now, what do we want to do? We want to change the x into a 4x plus 1. Now, I think what I want to do is first replace the x with an x plus 1, and then replace the x with a 4x. X goes to x plus 1. Why am I saying right and left? Oh, never mind. Do I want minus ones? Oh, I tried. Yeah, whatever, look. Whatever. Plus or minus, who cares? Me. There's this kind of common trap where you switch the 4x's, and then you switch the x to an x plus 1, and you end up with 4x plus 1, with this kind of thing inside, which is confusing, because the order that you did the transformations is not the order that the functions are being applied to x in the end. It's almost like the functions are being applied backwards, because at the end, the way you would evaluate this expression is to first add the 1 and then multiply by 4, but that's the opposite of... It's like inherently backwards. Yeah, the other way to understand it is to... So 2 ways to understand that combination. One is to stretch first and then translate, and one of them is to translate first and then stretch. You have to use different numbers in those cases, which somebody in chat says, wait, isn't it 1/4? That's because you're doing the stretch first, and then, yeah, so you would need to put in a factor if you're right. You would put in a 1/4 here, and now it's correct, right? But it's kind of weird that those translations are not the same as each other in the 2 ways of thinking about it. Okay. Goodo. Very silly turtles hate the sea. That's a new one for me. Oh, those turtles. Good, okay, what are we doing? Miles wants to transform by 1/4. Oh yeah, really? Yeah, there's a factor there, right? Oh, I don't know. Okay. We're going to find all the points that lie on both the x and the z. This is fine. Cool. I'm deleting all of this just in case there's minus signs in it. Practice yourself. Get Desmos to do some translations for you. Okay, x-axis and also the curve C. So these are points where I suppose we want the distance from x to the point A multiplied by the distance from x to B, which, because the y coordinates are 0 for all of these things, we want these things to multiply together to give 1. And there's kind of 3 possible cases. X could be bigger than 1, it could be less than -1, it could be in between. Those 3 cases give, I believe, the points √2, 0, -√2, 0, and the origin. The origin is easy to check, right? 1 times distance to 1 is also 1, you get 1. √2 is a little bit harder to check, and I'm losing confidence as I talk. √2 take 1, √2 plus 1, difference of 2 squares? Yeah, √2 take 1, difference to distance to B, distance to A, difference of 2 squares. 2 take over 1 is 1. Welcome to the Oxford MAT Livestream. Okay, personally spamming chat, it's now getting annoying, but you know, stream's free, you're having fun, we're all happy. Okay. Cool, so we've got these 3 points, and then we're asked to do this equation stuff, for which I think we need to do some distance calculations. So now we're working out genuinely for a different point. So genuinely for this distance, we would need to do something like genuinely writing down these distances. Somebody's just trying to, now in the same room as the people who are spamming chat, trying to dox the people who are spamming chat. This is fun. These distances, are, as I've written them down, are actually, there should be some square roots, but because the thing's 1 squared is 1. Okay. And then I think you can do some amazing difference of 2 squares stuff on this, right? I think you can just sort of multiply everything out. Oh no, I don't want to multiply everything out. I want to solve for like y equals. So that's a little bit tricky, a little bit awkward. Maybe I'll do something like this. So if I multiply out the first terms, I'll get this. If I multiply out the middle terms, I'll get this. If I multiply out the last terms, I'll get this, and I have 1 over here. What am I doing? Oh, this is a quadratic. for y squared. So solve, and then square root. Okay, not super excited about this calculation, but hey, it turns out that skipping through a lot of algebra so I can get down to story time. Okay. So this is an equation y equals, but if I just write out y squared equals for you, which is kind of the previous step before you took the square root at the end, you get something that's pretty much like the same as the graph we already drew, or the graph we already had, which got translated over a bit until it was going through the origin, like this. No, not like that. Yeah, like that, more or less. We have a graph like this, where now we've got y squared equals this, so x's have been replaced by x squareds and y's have been replaced by y squareds. Broadly speaking, that moves around the curve, it distorts it, and gives it lots of symmetry, because now if x is a solution, if x comma y is also a solution, if xy is a point on the curve, then also minus x would work equally well, because it would have the same square. And if also that point with minus y would work equally well, because it would square up just the same. So without even really thinking too much about the shape, I know this has kind of got like some symmetry, so that if there's like a blob of curve, if there's like a, let's draw an easier shape, if there's a blob of curve over here, which works, then there'll also be a blob over here, and down here, and over here, to kind of match up the x's and y's. Stuff above and below, nice symmetry stuff. Then I need to remember that I actually know some points that are on the curve already. We already found some points that lie on the x-axis and the curve, so I should put those on my picture. So I'm still remembering the symmetry, but I've now remembered as well that it goes through the origin. Okay, and the curve, broadly speaking, we found before something like this. We're only interested in the bit where y is positive, because we're going to do a big square root. So we're only interested in kind of some limited region like this, something like this. And then because of symmetry, there's a bit over here as well, because if x works, then minus x works. And there's a bit below where if positive y works, then hey, why not negative y as well, like plus or minus of this square root thing. So this equation that we have on y equals f of x works when we're in just that quadrant, but there's equally well some bits of graph in the other quadrants as well. And you end up with something that kind of has the symmetry of maybe two circles or something, but you end up with an infinity symbol. How cute is that? How did I find the turning point? Oh yeah, I skipped a part. X has been replaced by x squared, so take the square root of your previous number. Y has been replaced by y squared, so take the square root. Technically there's some maths that we should check to make sure that the deformation works like that, but for this I would just say, oh, this is literally the curve that we just have it with y squared instead of y, and x squared instead of x. So maybe it's a bit of a leap, but let's just take the square roots of the numbers we had before. Okay. How did I know that was the shape? Well, the function's kind of boring. It's just up and down again. Okay, it's been distorted to have x is replaced by x squareds, but who cares? And it's been distorted to take the square root, but who cares? It goes up, it goes down. For this, we marked this really generously. If people drew anything that went through the origin, they got a mark. If they drew anything that had some sort of symmetry, so maybe two like really square-looking blobs or something, that we gave them a mark. If people just drew like a really angular thing, that's also fine. We gave them the marks. If people drew something, oh, what else did we see? We saw a lot of stuff. Something really wibbly wobbly maybe, but going through the origin and kind of symmetric, and we give them a mark. The thing I like about it, of course, is that it's an infinity symbol. Story time! So when I wrote this question, I didn't know whether MAT was going to happen in 2023. We've got this online platform that we're using next week, but when I wrote this question, we didn't have that, and we didn't know if MAT was going to happen at all. I'm in charge of questions 1, 2, 3, 4, so this is the last one that the maths department is in charge of. So I wanted the very last bit of what could have been the very last MAT question to be something nice, something like, nah, we're here forever. We're going to keep going. I really liked the idea that you could be, as well, that you could be in the exam, draw it, realise that it's an infinity symbol, and go, huh, nice. And then maybe go home and check it and see, it's an infinity symbol. I've nailed that question. To be like, I just thought that'd be cute. And maybe a way to say, if this does turn out to be the last MAT question, then we ended on a high. Now, you'll be obviously aware that this is not the last MAT question ever. I mean, it's not even the last MAT question on this paper. So in some sense, the gesture doesn't work. But you'll be obviously aware that we are in fact doing MAT 2023. Here I am. It's not showing off. It's not showing off. We're all fine. Why does rooting preserve the turning point? Very good question. So square rooting is just a monotonic function, which is just an increasing function. It just gets larger. Let me try and explain. Here's a function. Sometimes large, sometimes small, sometimes okay. Here's my function. So you can see if you put in different values of x, you get different values of f of x out. I would like you to maximize square root of f of x. How are you going to do that? How are you going to make square root of f of x really big? I'll let you think for a moment. But because square root just gets bigger the larger the number is, I hope you agree that you want to go here, right? You want a nice big value. That's got the biggest square root. And that means at same place. Maximized. And that means that the turning point that was there in the original thing is now a turning point in this new thing. At current same value of x. Now it's complicated in the actual question because there's also a deformation that x has been replaced by x squared, which kind of moves it left-right, but moving it left-right doesn't change the fact that it's a maximum. So kind of the square root around the outside is fine, and then the x squared is kind of just the same thing but in a different direction. So it's all okay. What did I think 2021 would? No, I thought 2022 would be the last one. This is 22. This is last year. Because we didn't have what we've got now. Okay, that was story time. What a beautiful story. How do we know it doesn't continue off under the x-axis? It does, right? This one does. This one, my one doesn't. Okay. Hi, Alistair. Oh, where did that go? Where did that go? Where? Whoop. Did it come back? No, it's gone. Boop. I was about to answer it. There we go. So instead, for CS applicants this year, instead of doing question 7, you do question 3 instead. This is explained on the paper. You kind of can't get this wrong because there isn't going to be a question 7. But don't panic. There's quite a lot of past papers, and you've been looking at the right sorts of maths anyway. Tips for the multiple choice questions. Have a go at A first. The first one. Woo, where have we gone? There we are. 22. Look. The first one is supposed to be a bit approachable. So this one tells you that mod x means this. So there are 2 cases. So either x is greater than 0 or x is less than 0, in which case this would be x squared plus 1 equals 3x. Quadratic, relax, try and solve it. Or if x is negative, this would be minus x squared plus 1 equals minus 3x. Quadratic, try and solve it, relax. Check your answers are actually answers. Anti-Anonymous, why does the CS department get to write question 5? It is very helpful for the computer science department writes question 5. We like it a lot. And they write it to the same syllabus, right? So it's not like, the TS questions aren't weird. Maybe we should do a 5 or 6 or 7. I do want it as the format. The individual questions don't really have formats. They are just questions. Thought math started at 10. My school is starting at, well, if your school is starting at 9, please go at 9. I thought it was starting at 9 in lots of places. So I'm gonna go with, I thought it was at 9. Your school thinks it's at 9. Maybe you should be there at 9, just to see, just to find out. Good, okay. That's 1 hour down. We've done a couple of long questions. This one has got a little bit of a trick to it, in that you do need to check your answers down the end. Miles likes question 567. Your school's starting at 8:45. Maybe they want you to be in the room at 8:45, but who knows? Maybe they're going to start early. Let's look at 7. Oh, this is nice. This is some sort of data structure question in a way. I'd expect mathematicians to kind of be able to follow what's going on here. I think we're making valid sequences. The actual maths that we're using is not too bad at all. I think I've lost half this question off my screen. Never mind. Yeah, I've definitely lost half this question. We're not doing this question live. There are some instructions that we can follow. Here are some operations that we're going to do, and an example of what happens to make the output. And there's this kind of logic about putting things on the left or the right that we can follow through. Cool. Your school should know when it starts. There is also a page buried on our website somewhere where you can find out the start time for your country. Why are we getting rid of question 7? Oh, I don't know. The computer science department decided that they wanted people to do question 3 instead. Good, okay. I've only got the first page of each of these questions. That is not what I wanted. I could upload on my board. Okay, if we do 6 or 7, I need to go and find the other pages of those questions. Let's ask chat what we're doing next. And let's eliminate some options. Bam. Bam. Woomph. There we go. 3 and 5 in our drawing. Exciting stuff. While you're voting, I'm going to do some short questions. I think I'm going to start at J and work backwards. Am I going to regret that? Let's find out. Jay made the thumbnail for one of these videos at one point. Oh yeah, sanity check. It's on the clock. Don't forget to drink water and remember you're human, and blink if you haven't blinked for the last hour. Goodness me, I do sometimes worry about doing a live stream, especially because there's so much like high contrast. I've thought about whether I should put like a filter over the whole stream so that it's not so bright. I don't know if you've got something on your phone or something, right? That where you have like a nighttime yellow kind of lighting. Considered it for this, so like everything's a little bit yellow, so it's less. But anyway, blink. It's worse for me. I'm looking at 2 screens. Oh, Ben, legend in chat. Sorry, Ben's linked to test day start time in the United Kingdom is 9. There are probably some arrangements with test centres to do things that make sense. Does the MAT do error carry forwards? Yes, sometimes. I think whenever we do code forwards, MAT. Are all of the CS applicants just mathematicians? Yeah, I mean, the very first computer scientists in history were mathematicians, and a lot of computer scientists are still extremely close. Martin wants me to change the background colour. The problem is, the background colour is actually good. The background colour is this kind of like grey. The problem is the image is like imported. This is an imported image of the thing, so I don't know how to change the colour on that in this. I can apply like a filter to the whole thing afterwards in streaming software, but that's kind of not that fun. Oh, it's the video to the 2 hour video. Wait, have I done a 2 hour video? Wait. Did I do that? Chat, don't tell me. Have I already made a 2-hour video of the 2022 paper? I don't think I have. Let's just check. I'm gonna go to my own YouTube page. It'd be nice if I had, because then I wouldn't have to make one. Currently live. Yeah, no, I haven't uploaded a video in about a year. No, oh, we used it in a... I've definitely used this as the thumbnail for something. 10 months ago. Did I? We might go a little bit long. This is important to me. What am I doing? Where did I put it? Full paper run through for 2022. Oh, the MAT 2022 Livestream 2022 paper Livestream review. That was about 2 hours long, wasn't it? Thank you, Anti-Anonymous. Wait, timestamp. If this is a link to the current video, that would be so funny. Oh, yeah, okay. Yeah, it's last year, and it was about 2 hours. Cool. It's not quite a full run through, but it is like a version of me before. Thank you, Anonymous. I've talked about this question before. Play it back. Let's just put the stream. Let's just embed the stream on the stream, and we'll just talk about it. Oh yeah, no. So Jay is going on about quadratic equations, but if you stare at them, then you might realise that we've got this mx plus c thing. Where have you seen that before? Oh, you've seen it in expressions for a line, like y equals mx plus c. So if y is equal to mx plus c, then these equations become a little bit more familiar. They're the equations of circles. I think the justification for actually doing this is that we're looking for points that lie on both this line and the circle, so that you satisfy this equation and then also these. If you satisfy both, so if you're on line and the circles, if you're a point xy that's on the lines and the circles, then you could plug in the expression for y in here. And then repeated root would mean tangent. So we want, we've got two circles and we want to find lines, y equals mx plus c, that are tangent to both circles, like this. Isn't that nice? So the question really is just counting how many such lines there are. There are, I can't quite draw them, 4. Such lines. So this question is kind of geometry and algebra, but the wrong way around. We normally do geometry questions like this, where the trick is to turn it into an algebra question and then do stuff to do with the algebra. We've done that so many times. Geometry, but then you convert it to algebra. Algebra is your kind of comfort zone. You solve some algebra, do some discriminants or something, right? And that's very tempting when you see these to go, aha, b squared minus 4ac, except not c, the constant in this expression. But here it's the other way around. The equations are nasty, but if you convert them back into a geometry problem, then you can make progress. Yeah, so loads of people got that diagram but missed 2 of the lines. I feel bad about that actually, because you had the right idea. Just turns out the question at the end, how many lines are tangent to 2 given circles, is surprisingly hard. Didn't realise it was that hard at the end. So it's kind of 2 hard things together. It's not obvious, it's not obvious that you're allowed to do this, right? That you're allowed to just replace this with y. This is kind of a bigger problem. The two circles and a line. It's like a bigger class of problems. You've made it harder by asking me to think about just a random line and 2 circles and then remember that they're tangent. But that's the joke for this question. It's, I suppose, testing your ability to switch between algebra and geometry kind of style things. If you're really familiar with the equation of a circle, then you're happy going both ways. You might like to think about links between topics and ways where you could maybe reverse some of the things that you do. Like, I don't know, Quadratic equation, you know the roots. Maybe if you're given the roots, can you generate a quadratic? Maybe you can. Good. Why are they tangent? So each one has this repeated root, which means that instead of having, so if this is a hard problem with like general, just here are some circles, here's a line. In the general problem, if the line's not tangent, then you might get no solutions. You might get two solutions for where this crosses, or you might get one solution if it's tangent. Okay, I mean for each of these equations, for each of these circles, one solution, a repeated root, only happens when the line is tangent to the circle. That's the only way to get one value of x that works. Mumble, mumble, unless the line is vertical. Mumble, mumble, that doesn't happen because mumble, mumble, the circle is convex. Anyway, for harder algebraic geometry questions, you may need to consider some special cases where the line is vertical. Anyway, request for 1i, I think. General topics are for each question. I don't think we've ever promised that the topics are on general things. Oh, it's a probability question. Do I recommend further study? Depends what it is. I mean, I think I'm recommending university, so sure, yes. Factor theorem and got 4 values. Ooh. Factor theorem. I don't understand what that would mean, sorry. I can't see any factors. Factor theorem. Factor theorem. Gosh, you could kind of rearrange this one. Oh no, it's a different value of x. You can't just plug the equations together. You can't solve simultaneous equations on them. That's the annoying thing. The x values are different. Okay, 1i. And I've got a request for the end of 5. I don't know Professor Povey, but I have heard of the book. I did a master's and PhD in fluid dynamics. I saw you ask about fluid dynamics. Try not to talk about that now. It's extremely not relevant to what we're doing. You could say the story about question 4 was not relevant either, but I'm also trying to make you happy. Miles doesn't like this one. Good. Okay, I'm not going to tell you which questions I write or have written or will write for this year or future years. Don't at me when you see them. Right, good. Okay. Alice and Bob are each going to toss 5 fair coins. This question went through lots of different versions, so I've got to read it very carefully. 5 coins each. 3, 4, 5. 1, 2, 3, 4, 5. So here's Alice versus Bob. We're both looking for heads. The probability of this event is P1. So Alice wins P1. The game is a draw. Draw is P2. And I suppose the game's kind of fair, right? It sounds fair. So Bob wins with probability P1. So right away I've got 2P1 plus P2 must be equal to 1. Something happens. Either Bob wins or Alice wins, or it's a draw. Okay. The good way in, I think, is that there are lots of ways for Alice to win, lots of ways for Bob to win, but not that many ways for it to be a draw. So I think I want to think about P2 first, even though it's numbered 2, to think about P2. Which one of these is it? I guess this one's a joke where 2 of these are one of those. What if they're all equal? Not a good joke. So how would they draw? They'd get the same number as each other. Whoa, where did that come from? This equation. Either Alice wins or Bob wins, or it's a draw. I guess because it's fair, there isn't like a P3 for Bob, or if there is, it's equal to P1. Because, you know, for every world where Alice wins, I can imagine an equally likely world where they all swapped coins just before and Bob wins. For each of these, there's one of those, right? Maybe the coins were destined to come up in Alice's favour, but then what if the coins were destined to come in Bob's favour just by being the other way around? Yeah, so tip in chat about how we're going to calculate this. So maybe the game was very boring and there were 0 heads each, of which the probability is something like 1/2 to the power of 10. Or maybe there's 1 head each and like exactly 1 head each, so that it's a draw. There's different cases down here, right? 2, 3, 4, both got 5. Amazing game. Which is also pretty unlikely, right? 10 coin flips, all of them heads. Wow. Exactly 1 head each. There are quite a lot of ways that that could happen. I think it's 5 choose 1 to select which one of Alice's coins is heads. 5 choose 1 to select which one of Bob's coins is heads. But then 1/2 to the 10, because who says any of these things happen? And then there's a pattern that goes like this. 5 choose 4 squared. You kind of need to select for each of them which coins are going to be the ones that came up heads, choosing the same number for each of them. All of these things are multiplied by 1/2 to the 10. Any particular outcome is really unlikely because it involves 10 coins coming up. There might be quite a lot of them, so 5 choose 3 is quite large. And then I guess we've got to add a load of things up, which I'm not looking forward to doing, but let's go. 5 squared plus 10 squared plus 10 squared plus 5 squared plus 1 squared. Oh, that's not too bad. Divided by 1024. That's not too bad at all. That's 126 divided by 1024, which is divided by 2, 63 over 512. Is that an option? No, I'm out by 2. Oh, is that? That's no, I'm still wrong. I'm just wrong. Well, I thought I did that calculation really, really well. 100 I forgot to times by 2, didn't I? 126, yeah. Don't mind me just making silly mistakes. But I noticed it wasn't an option. I think it's A. I've just got this number. Chat will tell me if I'm wrong. Oh, chat's told me I'm right. 126 times 2! And then divide by 1024. I forgot the times 2, which made me look like an idiot on a live stream, but nothing new there. Yeah, these things are equal. Yeah, those things are equal. I could have noticed that. I noticed that over here when I was trying to do the addition, that it went 1 squared, 5 squared, 10 squared, and then that thing backwards. Could have saved myself some time. Awkwardly, I then tried to save the time by doubling, but I forgot to double. Good. I'm having a good day. We're having a good day. This was an experiment to throw probability back in again. We put probability on the MAT syllabus in 2018, I think. We didn't ask any probability questions for a bit. We tried asking some probability questions to see how it went. A little bit experimental. So far, the probabilities only really appeared in short questions, I think, in multiple choice questions at the front. So we're trying to work out how people find that, what sort of stuff. Did I look into Van Dorn's inequality? Hello, for this question after the last video you made on it. Wait, I made a video on this, and wait, oh, people think I remember stuff from the past. I'm very forgetful. I think I did, right? And then immediately forgot it. Quick bit of research. Oh, is there a formula for this? Oh no, there's a formula for this. Okay, yeah, I think I looked at the formula and went, oh no, this looks complicated. The only thing we need to know about probability, by the way, is this kind of binomial selection stuff. So if you're looking at these, like, where on earth did these come from? That's the only thing you need to know. I hope you agree. If you're worried about probability, that's kind of the only confusing thing here, is that out of nowhere I pulled all of these binomial coefficients. Maybe this as well, right? That things can add up to be 1. It's just kind of obvious. I don't know how often people look at question 1 working out. I don't get them to log it. I would look quite often, I think. What are we doing next? We're doing well for time. There was a request for like the last bits of question 5, which is jumping in a little bit. What I'll do is, so this question is really well structured in that it keeps extending ideas and bringing in new things along the way. You're looking for most of the question, you're looking for different patterns which fox the host, trick the host, so that whatever the host is going to do, your pattern of opening doors successfully gets you lots of distinct prizes. The host is unable to shuffle the gifts out of your way. And up to the last part, you're just describing these cool patterns which work so that you can do this. And it doesn't matter if you announce in advance what your strategy is. I'm going to open that door, then that one, then that one, because if it doesn't matter what the host does, you can just sort of like, I guess you're just sort of dunking on them, like you're actually telling them what you're going to do and like revealing your hand, like, oh, read them and weep. I'm going to open all of these doors and there's nothing you can do. And that's the mentality for the last part, because that fails. The mentality fails for the last part. If you have a way, a sequence, so down here, n equals 6, a sequence of any length, some winning plan that Alice can choose. If you've got a winning sequence, such that no matter what the host does, you're guaranteed. That's what guarantee means here. It's the word that's in the setup of the question as well. No matter what the host does, if you've got that strategy, then you can say read them and weep and hold out your strategy, show your cards for what your plan is to do. And then the way you prove this last part, the way you solve that doesn't work, is to say, in this case, the host can look at Alice's plan and outwit Alice to do something clever so that Alice never gets them with that plan. Importantly, we're looking for, in this last part, I'm mainly talking about the last part because it's hard, we're looking for a sequence, not a strategy that adapts along the way, but just a sequence of doors. A sequence of doors is just like a fixed sequence. There are strategies, I think, where Alice does stuff based on what has previously happened and thinks on her feet a bit, but that's not a sequence, that's a strategy. Maybe that's a little bit complicated. Matt is online on the computer. I don't know how logins work. I don't know how the admin of it works. I just write the questions. Some of the questions. I just coordinate. Let's get this right. I just coordinate the test setting process and live stream past questions. I'm pretty sure it will immediately self-end. If it immediately self-ends, then it's, I would assume, equivalent to submitting. I think it would be obviously insane if it threw away your work because you didn't press submit 2 seconds earlier. That would be mad. I don't want that. I want to give you marks for doing maths for 150 minutes. If you start a sequence and mess up halfway, I can't remember how we marked this. Kind of a clever thing to do is to also describe your sequence. Because that way, if you describe the sequence accurately, but write out some numbers and mess it up, then at least we can see that what you meant to do. So that's an example where showing you working out. Top tip: show you working out, or show some reasoning. Give us a tiny bit of writing, as well as the numbers. It'll take you a moment, but it might make it easier for us to give you the marks. You don't put the when you work online. No. You need the writing on paper. It's fine. No. I know. People will stress about everything. It's fine. My job is to reassure you that aside from all of the kind of admin stuff, I just want 2.5 hours of your time for you to do some maths questions, and then my team of grads to later look at your maths and give you some credit. So this is not all just like personal statements and predicted grades, but like actually you've done some maths and we've had a look at it. That's all I really want. And then all of the admin is supposed to make sure that in some sense that happens. So where an exam board might have to be very much like, oh, you didn't tick box C on the 4th of July in exactly the right direction, and I can't read that tick, I just want to see the maths. Why is it so long? Do you know what? Sometimes people want it to be longer. Sometimes people ask for more time. It's about as long as an actual Oxford exam, if that means anything to you. So it's sort of a bit like our actual exams on course. I think if we did it really short, then we wouldn't have time to give you so many questions. I like giving you this number of questions. Don't really want to give you any more questions. That's right. That sounds about right. Do all the right things, copied a number down wrong. Yeah, Miles is asking about error carried forwards, I guess, here. I reckon you can get quite a few marks. Having ideas is usually the hard bit. Somebody wants 4 hours. Running out of time is a genuine thing, happens to everyone, I think. The thing is, if I gave you an extra hour, everyone would get a few more marks, right? Because you'd do a bit more. Like everyone would get a few more marks if I gave you another hour. But it's diminishing returns because you probably get less done in that hour than you did in the first hour. So at some point we're just wasting our time, right? That you get an extra hour, you get an extra mark, and maybe the perfect amount of time is more than 2.5 hours, but that's already like your entire morning. So I don't want to ruin your lunch. That is a math question where you sort of invent differentiation. See, the math seems not specific. I actually make some guidance for markers that is more specific. It is not vibe based. I think in the past it may have been a little bit more vibey, but I am a control freak and I give markers very precise instructions. S has got extra time, there you go. Obviously, yeah, modulo, all the stuff I just said about extra time, obviously if you get extra time, multiply every number I said by the appropriate percentage. There we go. Make sure that your test center knows about your extra time as well. I don't know how the online platform behaves. I think someone somewhere needs to press a button to make sure that you get extra time in the system. Can you FOIA the other map marking guidance? No, because I think I cleverly destroy it each year. Let's find out. I think it's been destroyed. I don't think it's very useful to you, by the way. Precise marking instructions for graduate students. I don't think you need it in your life. I put enough stuff up out already, right? More. They want more. Give me more. Give me more. Minimum mark 0. We have shortlisted so many people with no marks. Either due to coronavirus, pandemic, some sort of injury. We've also shortlisted people with quite low marks because of pandemic, injury, mental health, other things going on in their lives. We've also shortlisted people with quite low math scores because we wanted to, based on the rest of their application. We don't actually have to have a reason. It's helpful if we've got a reason, but we do try and write them down sometimes. Yes, good. What was I going to say? Oh, I was answering EC's question about minimum mark, and I've gone off on a tangent. Why is it so early? Yeah, it's before half term, which is a decision made across the university by the central university and all the colleges that we would do it before half term. And half term is different in different places, so we're doing it nice and early. Are we doing any more questions? Yeah, I know. It sort of feels like I stopped, right? I don't want to stop. I want to talk about this integral a bit. I'm going to talk vaguely about questions and then sum up a bit, I think. Give you those advice. How did I find out people had COVID and personal problems? They submitted a special circumstances. Their test centre told us. And there's a reporting thing where test centres can say, oh, this exam. All of the fire that was happening during the exam burned all of the papers. That hasn't happened yet, as far as I know. We're avoiding half term. We do it mostly in schools and colleges, and it's really hard to do things in a school while the school is locked. So we're kind of avoiding that. Good. Okay. This thing's been squared. I can square that. A quadratic that went underneath, but then you squared it. N equals 3. Well, it was negative in between, so I guess it's like this. Like cubics. I'm trying to draw cubics. Points that dry on same axis. Labeling points in line by probably like 1 or something. No, where is it 1? Yeah, probably something like that. It goes through some points. Right here. Cool. Speedrun. Those zeros look suspicious. Yeah. X is plus minus 1. I see you. You know, 0, whatever the value of n is. Good. Okay. Explain why that thing is never going to be 0. Well, because this thing would be like greater than 0 if n is even. I guess greater than or equal to 0, but not always 0. Anyway, it's not going to integrate to 0. It's going to integrate to something that's positive. Yes. What is going on? I think special considerations is handled through the same portal stuff. I think schools can do it straight away after the test. I don't really know. This is one of those admin details that your test centre has access to some stuff. On the same axis, labelling intersections. Well done, James. You're now going to watch the next 2 minutes of live stream where I kind of improvised pretending that I knew what was going on. Good. If n is odd, then we do maybe get a point like this. I'll explain why it exists. Okay. So I see we got this integral. We got a shape like this, and we're going to integrate. So there'll be some negative contribution from here, and then some positive contribution to the integral as we do this integral. And eventually, this is huge. Eventually, so it will cancel out that negative bit. Good. Okay. Yeah, putting them on to telling you when it's 1 mark, telling you when it's 2 marks. That's the plan. Why do they multiply by 1/2 to the 10? Well, okay, so each one is describing something hilariously unlikely, where we're describing the outcomes like heads, 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 tails, tails for Alice, and heads, tails, heads, tails, heads for Bob. The probability that that exactly happens is tiny, 1/2 to the 10. There are quite a few ways in which you see 3 heads and 3 heads, which multiplies that up by some factor. But each individual result, heads, tails, heads, tails, heads, 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 tails, tails, that's pretty unlikely. Individually, the things have to add up to 1, so no, individually they have to add up to. That's complete nonsense. Overall, the probability's got to be 1, so there's got to be some division going on. Okay, what's going on here? Find A1. Okay, it's not too bad at all. This is find the number such that I can't even write. Why are we? Why must we do this? There we go. M is 1. 2m minus 1 is 1. Okay, I've solved this. Right, so we've got to do some integration. And then over here, for A2, we're asked to work with this thing, which is, I believe, as being cubed. Yes. This power is 2m minus 1. M is 2. 4 minus 1 is 3. Quick maths. Bother, I missed the chance to say 2 times 2 at the start. Anyway. 2 times 2 is 4. Minus 1 is 3. Quick maths. Oh, there we go. Couldn't resist. So over here we've got a slightly harder polynomial to integrate, but we're going to go and integrate that polynomial. We're going to go and integrate that polynomial. Oh, how to prove A2 is less than A1? Oh, it is sort of... I think it's true that A1 is root 3. I think you're right. Quick sum. Yeah, you want to put root 3 into that. But then this root 3... Miles wants to prove that A2 is less than A1. It's actually easier to prove that A2 is less than root 3. Those are equal, but it's actually easier to leave that as a root 3. I know it's quite tempting to interpret this as a proof that A2 is less than A1, but actually you know quite a lot more about the number root 3 than you know about the number A1. Even though they're equal, right? You know loads of stuff about root 3. It squares to 3. From the equation over here, you don't really know that A1 squares to 3 when you see it. You have to work it out, and then you go, oh, it's root 3, so it squares to 3. Anyway, over here we've got some sort of horrible polynomial to work out, which starts like this and carries on rather for 5 over 5 and so on and so on and so on. There's a load of polynomial, which is then evaluated. Oh my goodness, evaluated at A2 and 0. So you get some horrible mess, sort of polynomial with A2s in it. And oh my goodness, we can do some sort of like sign change stuff to see whether A2 lies in a particular range, because we've got some hideous polynomial. How does the integral help? It seemed like a mess to me. The integral defines AM. It's the only thing we know about A2. The only thing we know about A2 is that the integral from 0 to A2 of x squared minus 1 cubed is equal to 0. Believe it or not, that is, when we start, the only thing we know about A2. We're later going to find out that as a result it's this. But you've got to work with this integral a bit, because that's the only thing we know about A2 when we start. Good, okay. I suppose my explanation is about this like area balancing out. To interpret this as an area, and to say there's a negative contribution and then the function is very positive forever. Eventually the areas will balance out. I can also do that by like kind of arguing about polynomial degrees of a polynomial, but don't love it. Oh no, you mean how? Okay, right, sorry. Mean that you got that polynomial. How can we use that to prove? Oh right, okay. So you've got a hideous polynomial. You know that. I'm going to give it a name to make it less horrible. You've got this horrible polynomial, which I suppose is horrible polynomial evaluated at A2. They get worse every time, don't they? Horrible polynomial evaluated at A2. Now, what we can do is check that horrible polynomial with, okay, I suppose we know that this thing is equal to 0, because that's what A2 does. You integrate up to A2, you get 0. So we've got horrible polynomial, and this point here is A2, where the polynomial is equal to 0. So what we could check is that, and this is a bit sneaky, that at root 2, the polynomial is negative, and at root 3, it's positive. I think it's that way around. And then in between somewhere, there must be a point where the polynomial is 0. Polynomials join the dots, right? If it's negative here and positive here, then in between, it's somewhere. It's going to be 0. Oh, if I missed an influence. Oh, there, question 6, influences. Okay. And then the idea for the last part is just that thing I said about the function being huge and getting fast very quick. That means that it cancels out the negative area extremely quickly. And you end up being near that point, which I didn't label on my curve because I was being lazy up here, but extremely near there. Extremely near there. The thing. For a value of a very close to root 2, the integral from 0 up to a is 0. It only takes a tiny bit going past root 2 for the thing to blow up. Super huge. That's not root 2, is it? That's 1. That's 1. Root 2 is up here. The signed area is counting areas below the x-axis as negative. Thank you, real for Matt. Oh, chat, what's chat say? How can you compute p root 2 without a calculator? It's not that bad. I mean, when you plug in root 2, that's actually quite nice because we don't need to know the exact value, I suppose. We just need to check whether it's positive or negative. As you start plugging it in, all of these terms have got a factor of x in them. So maybe it makes sense to write p of x is like equal to x times x to the 6 over 7 minus 3x to the 4 over 5, plus there's a bunch more terms. When you plug in root 2, the powers are all even, so you just get things involving 2. The root 2 up front doesn't affect whether the thing's positive or negative, so you just have like a bunch of fractions. Maybe this question paper had a little bit too much calculations where you wish you had a calculator. Maybe. For part 1, I would just draw it, right? Yeah, I would just go for it. If it was a polynomial, I wouldn't differentiate for the turning points or anything. Just go for it. With the sketch questions, we're expecting a sketch, really. You can show some working out if you like, but mostly going to look at the sketch. Cool. Reese says, hugs and kisses and good luck. Have we talked about signed area? Yeah. Anonymous, yeah, this. If you're asked to calculate an area of a region. Woo! here's the awkward thing. Area of a region, you want to do, maybe like you want this region over here. Kind of awkward. This thing should be positive or 0. So you might need to do the integral of f of x from here. This is like minus 3 or 0 or something. You might need to do the integral and then take minus that, or like take the absolute value of that. You might need to do something like that. The awkward thing is that the integral gives the signed area, which might be positive or negative. Signed as in it's got a sign on it, maybe a negative sign. And there's this awkward thing that like if your function crosses the axis, then it's kind of doing one thing in one place and one thing in the other place. If you're asked for the area of this region, then there it is. If you're asked for the area of the region here, it's kind of awkward because you've got to split it up. I have a hot take about area, but you know, nobody wants my hot take is that we should embrace this. Signed area is the real thing because it actually corresponds to integration. So forget this kind of idea about area for a region being positive, just chuck it away. Forget that. Let's just deal with the idea that areas can sometimes be negative and sometimes be 0. It's a hot take because you end up saying things like the area inside this curve is 0, kind of because half of it is upside down. So it's kind of 0. People don't like it. People want the area inside an infinity sign curve to be non-zero. I sort of get where they're coming from, but no. Hot take. This question was based on factorization that I've seen and like. So I showed it to you so that you would learn it and then ask you a question, because I have to ask you a question. But really, my interest in the question kind of stops here. I wish that I could set a question which was just like, for all real n, it is the case that n to the 4 plus 1 equals this. And then the options would be A, wow. And there would be no more options. And you would select, wow, that's all right, that's great. I can't set that question because you'll all get it straight away. I'm required to make them hard or something, so fine. I asked you to factorize something else. Well, I don't ask you to factorize, I ask you about prime numbers, but come on. We're going to try and factorize this. Can you understand this, what's going on in here? And there's kind of a direct way, I suppose, and an indirect way where you take like you can take like n is m over root 2 or something mad, and then multiply both sides of this equation by 4 or something, and then it all works. But how are you going to think of doing that? Something you could do instead is just sort of try other values. You want kind of some ratio of root 2 is going on in here, so you could try throwing in extra root 2's. Anyway, it turns out that this is n squared plus 2n plus 2 times n squared minus 2n plus 2. Kind of related expression. Quick, change one of them. Here's a cool fact. Wow. That's what I want. So the question is like now broken down to, hey, we worked out this in factorizers. Wow, that's kind of a nice fact as well. And I think this is the first time I saw it was like this. So we've given you a related fact that's still pretty cool. This is the difference of two squares, right? This is a square. This is kind of a square if you squint. It's the square of something stupid. So it factorizes. I have a kind of joke about the difference of two squares that I'm workshopping. I'll do it at 7. Yeah. So now we're looking for are these equal to 1? Because if this is supposed to be a prime, then we're supposed to look for whether these things are the number 1 or not. And I think one of the brackets could be 1 and the other one definitely can't be 1. I'm a bit rusty, I can't remember how this works. Yeah, I guess n is like, we're looking at positive whole numbers n, so I think maybe this is just like obviously too big because 1 squared plus 2 then is huge, definitely not 1. If this thing is prime and it's factorized, then one of these things is 1. Or minus, no, forget minus numbers for now. This bracket's positive. What have I got? Maybe n squared minus 2n plus 2 is equal to 1. I guess that could happen if, hang on a minute, n would have to be equal to 1. In which case I'd be looking at the number 5, which is prime. But that's it. Oh, they can both be 1, but it gives the same thing. What's signed area? What is chat talking about? What is chat doing? No, wait, I see. It was a great joke from Real Format that I didn't read out. It's back on screen now. Everyone appreciate this joke. Good. Could you please explain this question better? I don't understand everything you say. Cool. Question gives you a remarkable fact. And the first thing I want to try and get a 4 in here is to multiply both sides by 4. That will give me a 4, I hope you agree. I'm going to multiply, and some other junk. I'm going to multiply each of these brackets by 2 so that I'm being fair to both the brackets. Just keeps it nice and pretty, right? Now this is not quite n to the 4 plus 4, but if I rearrange this a little bit, I can write it as this is something to the 4 plus 4. So maybe I'm going to get a fact where I want to kind of change variables and do some multiplication, because I've noticed that this thing here is root 2 times n squared, and this, if I squint here, has got a root 2 times n, and this has got 2 in it. And then it's kind of very similar terms over here. There's a 2 here. There's a 2 there. There's very similar terms over here. So then my kind of amazing idea is to write m equal to root 2n. This fact was true for all real n, so I can do this kind of thing. And then I'll get this brilliant fact that makes me smile, which is that m to the 4 is 2n plus 2, m squared minus 2n plus 2. It's kind of classic difference of 2 squares, really. If this thing is supposed to be a prime number, then I have follow-up questions about this factorization that we've done, and then there's just a few cases to check to say no, doesn't happen. One of the brackets is 0. Well, 0 is not prime, so we'll be okay. Factorize it. Why you set that factor to 0? Oh, I set the factor equal to 1. So a prime number p is one where the only factors of p are 1 or p. Only factors 1 or p. So if this is a prime p, this thing here is either 1 or the prime itself. If it's 1, then I have follow-up questions. If it's equal to p, then that term is 1. And I have follow-up questions. These are quadratics, I can solve the quadratics. One of them doesn't go anywhere, the other one is good. I have missed a 2. Yeah, this is the Sophie Germain identity. It is cool. I have missed a 2, but that has forced chat engagement. What is a prime number? Something whose only factors are 1 and prime. If you'd like these flashcards that help you revise maths topics, you can get a copy on the MAT website. I mean, you can get something to print at home. If you print them out, you probably want to stick them to some sorts of card. If you've got 60 copies of a business card or something, then that works well. If you've got 60 cards from your favourite collectible card game, then they might fit on those. But watch out for any valuable collectible ones. It would be terrible if you stuck the definition of a prime number to a black lotus. That would be a terrible use of prime stickers. First one, the smallest one. Oh, yeah, but no, you've been cleverer than me. Cleverer than me. Multiple choice questions, so you can take any like fast, cool tricks you like. Yeah, I agree. That one's smaller, isn't it? Primes are bigger than 1. Yeah, good. Extra key 120. I don't really want to do videos on the extra questions. I don't think they're my greatest questions, or I didn't write them all, but hey. Oh gosh. So I need to tell my friend Ben that you said this. How do you start to write these questions? This particular question, I was having a chat with my friend Ben, My friend Ben said, have you done anything with Sophie Germain's identity, basically? And said no, and then from that idea, it's pretty easy to write this question. The point is it factorizes, so then you throw in the word prime and see what follows as a consequence. The thing that follows is a pair of quadratics, at which point you know you're onto a banger math question, because math questions are allowed to do quadratics. But shout out to Ben. Chat likes your question. First few of the online flashcards. Wait, are you using the Cram website? We linked to this third-party website that hosts them as well. If they're broken on the Cram website, I can try and go and fix it, but it's external. Hey! We're not doing 23 next week, because next week we are going to do the 23 paper. Do I have a favourite math question? Right, okay, we're going to wrap up a little bit here, because we're about to hit 7. What did I tell you I would do at 7? I can't remember. About 5 minutes ago I said I would do something at 7 o'clock. I'm losing track, chat. Was it learn Vandermon's identity, which I noticed I have a tab about that. Maybe I need to learn that fact about identities. What is my favourite math question? Oh, I really like the question about logarithms from 2021. Question 2, 2021. I think that's a very good question that I wrote. A story about something, a joke, some sort of a joke. I think the clock counts down, but I'm not sure. Was this made by Andrew? Was that made by Dan in chat? I can't remember. Sorry, Dan, if you're watching and I've forgotten your name. Card flip is also good. That's not appropriate. A joke about difference of two squares. Oh yeah, a joke about difference of two squares. Okay, it's not a joke. Cram doesn't have pictures of the first few. Oh yeah, I've been workshopping a joke. It's not a good joke. Right, let's do this. So the joke is that whenever something factorizes, you can say, oh, did you spot the difference of two squares? Like whenever something factorizes. Because if it factorizes into anything like this, if it factorizes, then that is p of x plus q of x over 2 squared minus p of x minus q of x over 2 squared. So whenever you see something factorize, like you say x squared plus 4x plus 3, well, that factorizes into x plus 3, x plus 1. But a different way to say it is, aha, did you spot that that's the difference of 2 squares? It's x plus 2 squared minus 1 squared. And this maths on the screen gives you a way to convert any factorization into the difference of 2 squares. And if you can run this quickly in your head, to run x plus 3 plus x plus 1, that's 2x plus 4, divided by 2 is x plus 2. If you can run that quickly, then you can point at any maths that someone else has done where they factorized a thing. And you can say, oh yeah, it's obvious by the difference of 2 squares, right? Where the squares are p plus q over 2 and p minus q over 2. And if you can work those out really fast, then you can point at any factorization and say, yeah, it's just the difference of 2 squares, I think. The difference of 2 squares fact is directly equivalent to factorizing anything at all. That is the joke. Andrea likes, shout out to Dan, yeah, great game. What is that? 5 million summer camps. It would take a while. Doctor Who is applying. Doctor Who has seen 5 million universes. Wait, no, that's Doctor Strange. I don't know. If you've done a lot of summer schools and maths outside of the class stream, that's nice, but I am still going to make you do the math. It's not really a math joke. It's like a template for a funny maths experience in your future. You can try this out for me. It's an abstract level of a joke. It's not actually the joke. It's a kind of formula for producing jokes. Right, okay. Not a joke, it's an interesting fact. My school's told me to bring headphones. I have no idea what's going on there, Karen. No idea at all. Different circles. What's your number one number? Number one. How do I get the fractions? Oh, I've worked them out on a scrap of paper before. It genuinely works, right? Because this is 2p. I'm using the fact that this is like this. I know I'm aiming like this is the thing that I really want. And then all of the divide by 2s are like to make sure that the 2s go away. And the difference is like, because I'll get this with a plus or a minus sign. So I'm exploiting that fact. Not like original fact, but turning into a joke. Yes, y plus 2. Yes, chat. Yes, here we go. Y plus 2, that factorizes as y plus root 2. Y minus root 2, root minus 2. Brilliant stuff, which probably you spotted because it's the difference of two squares, right? Yeah, difference of two squares. This is a format for a joke, right? Okay. Right, good, okay. Good. I'm going to say, who is Matt? Your school told you to buy headphones. Sorry, okay. The Matt Livestream's very noisy. I'm quite loud. The Matt itself, totally silent. It's an exam. I don't understand the headphones thing. Bit misleading. Hence from that. Oh, hence means you have to use it from this. Yeah, I don't understand. Right. Can I solve a Rubik's Cube? No, I've tried. Cannot work it out. It's not a difference and neither are squares. This is a minus sign. This is a minus sign. There's some squaring. I didn't say what the squares were going to be. Why are we using the test for Matthew? Why can't Matthew do his own test? Brilliant stuff, chat. We're on fire. Final tips. Let's go. So you've watched like 2 hours of live stream, and if you watch the other ones, you've watched hours of content. Let's try and boil it all down. It's maths. You're good at maths. Ooh, I'm not good at writing, but you're good at maths. You've got this. Let's not do the therefore dots, that's a bit gimmicky. You've got this. So I put my name on it as well. That'll do. Next year, I'm just going to put this on the screen. It's just going to, these 3 bullet points, and I'll sit there in silence. No headphones required. Just. You've been practicing maths before. I would like you to do a few maths questions so that tutors here can see that you can solve a few maths questions. Not all of the ones, not all of them that I'm going to give you, but you can have a go at having some clever ideas. I hope that you find the opportunity to have some clever ideas during the mat. I hope that in some sense you get to demonstrate what you're doing. Did I get the y plus 2 wrong? I get the y plus 2 wrong. Oh my goodness. Right, good. Okay. Ben noticed that I panicked. Yeah, Ben saw that I panicked about apostrophes. Yep. I know what it's like to not quite know what you're doing and then to get there and everybody's going to see, but you have to do something. And it turns out that I can do apostrophes, and I think you can do maths as well. The thing I really want to say at the end here is this isn't the end. You'll look back on this as a weird exam that you did for some universities before you went on to do maths at university. And all the maths you did at university was more interesting and more important than the maths you did before, and definitely more interesting and important than the maths that you did here with me. But I hope that the problem-solving skills you've been working on, the kind of other stuff, not the difference of two squares and not the how large is a triangle, but the kind of problem-solving stuff and the perseverance you've developed and the way you keep trying things and get unstuck. I hope that stays with you, and that later on in other exams or university or even real life, being the sort of person who solves problems and does stuff and just goes out there and has a go, even though it's scary, and even though you don't always know what you're doing. I hope that's helpful. So I wish you all the best with maths. Maybe I'll see you around on some other math stuff in the future. People in chat were saying they bumped into me on open days or workshops or other things. I was in somebody's school earlier this week. Maybe I'll see you around. Maybe I'll see you in the Thursday slot in January for Oxford Online Maths Club, which is like this but fun. We do actual fun math topics instead of math questions. I'm doing some bonus live streams as well on a few Thursdays scattered through the next couple of months. Maybe I'll see you round in Oxford. If you come and study here, say hi if you see me around. Otherwise, have a good one. I've also got a Twitch channel now, and I'm going to really unprofessionally plug my Twitch channel that I think I might start doing some like Sunday stuff. I don't know, I'm thinking about doing Sunday maths. Hang on a mo. Let's just do a create poll. It's just totally unprofessional, but like Sunday not chill streams on Twitch. Yes, no, maybe? Maybe. So it's not like a good use of the platform, but hey, I did some Twitch stuff recently. Miles wants to go on Maths Club. So I'll do interview questions at some point. There's a bonus live stream. Let's quickly look. Official content from the University of Oxford. Let's have a look at the webpage together. I'm opening the webpage that's on the stream. Here it is. Oh, and I'm logged in, so anything could happen. We are now here. Oh no, we're here, and I haven't put a link in. There are 3 more bonus other maths for a sample of what Maths Club might be like, or just other fun stuff, you know. Maybe all different to two squares continuously, nothing else. Bonus stream that's about the paper we're doing, but we'll do that later on when the dust has settled. And then I'm doing a bonus stream on interview questions on, it says here, the 30th of November. Then that gives me a month off before Math Club starts in January. Chat has spoken, the people have voted. Some people are here and they would like some sort of Sunday not Matt chill stream. Right, cool. Okay, let's announce that then. People have spoken. I will do like 2 PM or something. We'll just do like chill things. Cool, let's do the announce. Let's not use the stream. Right, cool. I will see some of you. Look at me plugging my social medias. So I have a Twitch. I will see some of you on twitch.tv/James Munro. Look at me dropping my socials for a 2 PM chill Sunday. What is it now? 12th, 13th, 14th, 15th October. Oh, the UCAS deadline. We've got almost the UCAS deadline. But we're not going to talk about UCAS. Not UCAS. Not Matt. Not UCAS. We'll just do some maths. I think that's what I want to do. To be honest, I've got so close to a Twitch milestone that if I do one more live stream, even if no one turns up, if I do one more live stream, then Twitch, I tick a box on Twitch. You don't need to put Matt on UCAS. Right, let's do the important bit that's not plugging Twitch. I'll see some of you. Yeah, okay, good. Oxford Online Maths Club is just like this. It is on this channel. If you are subscribed to this channel, it will just turn up. You don't need to do anything, Luca. You're in the right place. My Twitch handle is my name. I don't really understand Twitch, but I think I got my name. Chill maths. Should be fun. Right, good. Okay. I guess the point, in case my employer's watching and wants to know why I'm plugging my social stuff, I think that what we've got here is a collection of mathematicians, maybe not all of whom are going to be at Oxford, but mathematicians are going to go and do interesting stuff in other places. And they definitely don't want to hear math stuff after the exam, but I might want some other stuff. Lo-fi. Yeah, it's a lo-fi. Let's call it that. Chill lo-fi. You get that music channel on with the headphones. People say thank you. George W, when do we apply for Matt? So it's next week. You apply about a month before the test. So if you haven't applied for this one, don't worry about it. It's too late now. If you're applying for next year, please look up the deadline in advance. I really hope this is not George W. discovering the MAT thing, which is next week. No, it can't really be, right? Surely this is not a real thing. We're going to smash it, Nav. We're going to get there. Good. Good, yeah, I hope it goes well for everyone. I'm signing off, I think. Yes. I see some of you on Sunday on Twitch. Just sort of hang out with some maths. Poor George, yeah. What a sort of odd note. Could George just be like, yeah, we're still here. Matt does not need to be on your UCAS application. Yeah, we don't. If you don't put it on UCAS and do the math and you get linked up, it's all going to be fine. Good, right, okay. Bye. If you've seen any of my streams before, I have no idea how to turn them off. Not joking. There it is. Bye.